For this Fun Fact Friday, I want to look at the Greek influence on mathematics, specifically the linguistic influence the Greeks have had in math. So you may or may not know the very first mathematics textbook is Euclid's Elements. Okay. It's a really interesting book to read through. Obviously, you need to get a translation because it's all in Greek. But this was the beginning of math as we know it. And so it had a big influence on the mathematics of today. So let me show you some ways that comes about. So for example, here I have some shapes. This first shape, I'm sure you've heard, called a hexagon, right? This second shape, a heptagon. If you're familiar with music, you know that if I have a group of 6 instruments or 6 singers, it's actually called a sextet. And if I have a group of 7, it's called a septet. Or if you think in terms of months, we have September. So what's going on? Why is the prefix sometimes with an S, sometimes with an H? Well, that H is coming from the Greek, and the S is coming from the Latin. So it has to do with Greece and Rome back in this day and age. So hexagon, that agon prefix, that's actually a Greek thing. Because it's geometry, we use a lot of Greek words. Whereas the tet and the ember, that's a Latin ending, so we use the Latin prefix, okay? So you can also see this with a hemisphere, right? If you think in terms of the world, we have hemispheres. So for half, we use hemi. The one exception I can think of, I'm sure there are more, is semicircle. Instead of saying hemicircle, we say semicircle. For some reason, we like the Latin word for circle, so we use the Latin prefix. I don't know why, but that's the one exception I can think of. But that H is typically from the Greek, and that S is coming from the Latin. So there's more influence the Greeks had. So for example, you may have wondered, or may not, but now you will, why do we have special names for the 2 and the 3 exponent, but not anything higher, right? We say a squared, we don't say a to the 2. We say a cubed, we don't say a to the 3. But we say a to the 4th, a to the 5th. So why did these two get special names? And it goes back to that Greek influence of geometry. When they say a squared, they literally were thinking of a square, of the area of a square. When they say a cubed, they literally were thinking of the volume of a cube. So that's where those words come from, and they're a holdover from that. There is no good real-world depiction of a 4D cube or a 5D cube, even though we deal with those in higher math. The Greeks weren't thinking of that because there's no good real-world depiction. While we're looking at squared, that leads me to thinking about the Pythagorean Theorem. So when ancient Greeks say a squared plus b squared equals c squared, they weren't thinking a number squared, right? They were thinking of a literal square and its area. So here's the picture they were imagining. I have my A, B, C for my triangle. And notice, I have a square with area a squared because it's a by a. A square with area b squared because it's b by b, and so on. So, the way they verified the Pythagorean Theorem, it's really neat actually. Euclid came in and noticed if he went from the right angle and dropped a perpendicular, down, 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 all the way down, he noticed that the area of that a squared matches the area of this little rectangle. And the area of the b squared matches this rectangle. And he actually proved that, okay? So they literally were thinking the area of that a squared and the area of that b squared, I can combine them to create the c squared. So that's what they meant by a squared plus b squared equals c squared. Nowadays, we actually have hundreds of different ways to prove this that are a little simpler than this. Actually, one of them is attributed to President Garfield, came up with one. So I recommend, if you've got some time to just play with math, look on the internet for a bunch of proofs of the Pythagorean theorem. It can be fun. All right, so a little tangent off of that, just because I think it's cool. You may remember from high school algebra this crazy distance formula. You may have had to memorize it. So what I want to show you, if you've never seen this, is you never have to memorize this again. Okay? I want to show you what this really is. So let's think about this distance formula. It's saying if I have 2 points, I don't know, something like that, and I want to know the distance between them, you plug in that x and that y. That's a really bad drawing of the line, but go with it. Well, you actually just need to do Pythagorean theorem on this. If I find the change in x, I'll have one leg. If I find the change in y, I'll have the other leg. That's my x2 minus x1, y2 minus y1. Pythagorean theorem says you square both, and then take the square root of the sum to find the hypotenuse. So let's see how this works in practice without having to use that formula. So, I don't know. Let's say we're at this point. So that's 1, 2, and this point, which is 1, 2, 3, that's 4, -1. Instead of doing Pythagorean theorem, I'm just going to say, all right, it traveled 3 in the x direction, 3 in the y direction, so my hypotenuse will be 3 squared plus 3 squared square rooted. So square root of 18, or if you prefer, 3 square root of 2, same thing, okay? There you go. And that's exactly what you would have gotten if you had plugged into the original formula. So that's a nice use of the Pythagorean theorem. You don't have to use the distance formula. It is just the Pythagorean theorem. So just use Pythagorean theorem in the first place. So anyway, that's your Fun Fact Friday about Greeks and mathematics.